gathered here to discuss about the topic impulse response of linear time invariant discrete time system. Okay, so you know that we are following design thinking approach in our college. So there are 5 different stages in design thinking. First one is empathy, to identify the user needs. Then define, we are going to define what we are going to do, and then which is ideate, so how we are going to perform, and then prototype and test. Okay, so before going into the detailed explanation of impulse response, so we need to know what is impulse response, so and where it is used. So impulse response of an LTI DT systems are mostly used in digital signal processing applications. So LTI is nothing but linear time invariant systems. So it should satisfy the property of linearity as well as time invariance. So linearity, it means it should satisfy the superposition principle, and time invariance is when there is a change in the input, then correspondingly the output also should get changed without any delay. Okay, so if both of these properties are getting satisfied, then it is known as an LTI discrete time system. Okay, so LTI DT systems are usually represented with the help of difference equations. So we have to analyze, if we want to analyze the LTI DT systems, we need to go for some type of response which is known as the impulse response. Okay, so today we will see impulse response of an LTI DT system. So before going into that, let us discuss among each other, and after that we can share the points. Okay, so you can start your discussion. Okay, I hope you would have discussed among yourselves. So can we start to share the points with each other?
Yes.
Okay, who's going to start with the empathy part?
Myself, ma'am. So hello everyone, I am Tani. I am here to speak about the empathy part. So empathy is first stage in design thinking, and empathy is about the understand the needs, problems and feelings of the user, and by standing on their shoes. Here we focus on the students and engineers who study about the LTI systems. The main struggle, they focus on how the system will respond when a signal is given as an input. So they struggle how it will respond. Too many equations, they struggle to understand it. To overcome this, we need an impulse response, which we give a signal as an input, which gives the behavior of the system as an output.
Yeah. So to check the behavior of the system, we need to go for the impulse response, as Dharini said. Okay, next who is going to tell about the define part?
I'm going to talk about the define part. So I'm Yoganala. I'm going to talk about the define part. So define part is said to be a second stage of design thinking, where we will be concluding our problem statement for the problems that our users face. So here the unit impulse is also called as a discrete time delta function. So here the unit impulse has a non-zero values, and also the zero values for the n is equal to n, or n is equal to 0 values. So here it is used, it has a many fundamental roles in digital signal processing and linear time invariant. So the system response can be determined by expressing it in a shifted unit impulse and being its convolution. Thank you.
Yes, the response of the system for a unit impulse input signal is known as the impulse response of the system. Okay, so next who is going to tell about the ideate part?
Ma'am, I will continue with the ideate part. As a brief intro that given by you about design thinking, I will follow the ideate portion. So here we explore the concepts through analogies and visualization. So first is brainstorm analogy. In that we will see the echo analogy. So for example, once we clap in a hall, the sound gets reflected and gives impulse response. And second is mechanical analogy. Here once we hit a spring, it gives a vibration and gives system response. And the third one is digital analogy. Here we see when input is given as impulse, it gives a system response and gives an impulse response. The second one is a concept mapping. Here we teach the students how to visualize and draw the concepts, and that is impulse input and system output.
Yeah, for impulse input, how the system reacts, right? Okay, so next who is going to talk about the prototype part?
Hello everyone, I'm here to talk about the prototype part. So prototype is basically fourth stage of the design thinking. Here the impulse response
shows how the system reacts when the impulse response is given as input, and observe the output as the full behavior of the system. Here we consider the three methods. First we consider the difference equation. Here we set as input impulse response as input and observe the output step by step. And the second one is the Z transform. We apply inverse Z transform as input and observe the output as step by step too. Finally we consider the direct observation or conversion. Here we observe the output, how the input we given to them.
Yeah, yes, Yamuna said. So for analyzing your difference equations, you are going for a Z transform because it's a discrete time system. So you will be taking Z transform of the given difference equation, and then from that you will be analyzing either by giving the impulse input how the output is got. So Z transform plays a very important role in your analysis of LTI systems. So next, who is going to tell about the testing?
Everyone, I'm going to talk about the testing part, and testing part is nothing but we are testing a product. So how does that work, and we have to improve the designs when compared to the previous one. So your impulse response is nothing but testing a very short input and check whether system reacts well or is there any problem or what, and analyzing the whole product and giving the output. And in design thinking process, it involves in understanding the improvement or is there any changes or problems. So it makes engineers think and design, analyze how in a very short period how they can give the answer, and it is nothing but analyzing the whole process with a single input, so we can understand what is the need and what is improved and what is to be done in the future in advance also. Thank you.
Okay, good. So I'd like to add one more point here. So you'll be given with a difference equation. So you want to analyze that difference equation. So what you will do is you'll be taking Z transform of that given difference equation, and you will be obtaining H of Z from that. H of Z is nothing but you know that it is Y of Z by X of Z. So from H of Z, when you take inverse Z transform, you will be getting the impulse response of the system. Okay. So here in impulse response, your X of N will be a unit impulse signal, so where you will be having value only for N is equal to 0. So when X of N is that, you will be applying that as the input here in the equation for X of Z, and you will be calculating your H of N. So this is your impulse response. Okay. So thank you for sharing your points. Thank you everyone.
Thank you, ma'am.